few years and somehow big data influencers list, which is pretty funny because I'm sure I know less about big data than anyone else on that list. But here I am, and that's how I got to be the moderator for this panel. So I'm just going to go through quickly, introduce our panelists. Those are all in the conference materials except for Tiffany, who joined late in the process. So I'll just start with her. Tiffany is Executive Director of the National Space Society Silicon Valley chapter. Is that correct?
More or less, yes.
Okay. Well, more or less, and has written extensively about it. Again, knows far more about it than I do. And I'll just quickly go through our other panelists here. Or actually, why don't I let them introduce just brief who you are and what you do and why you're here.
Hi everybody, and thanks for having us at the NewSpace conference. So I'm Pablo, co-founder of SpaceNo. We are a software startup in San Francisco, and what we do, we analyze, we talk to all the imagery providers, like Jason, for example, and we work very hard to basically unify all the EO constellations out there in the world to derive specific information. In other words, our clients come to us for specific insights about specific locations in the world, and we build finished solutions that give them the ready-made consumable answers, and we also give them tools to derive their own answers.
I'm Tiffany Crawford. I'm president and founder of the Space Society of Silicon Valley. The interesting thing for this group, I think, is our two centers of excellence. We have space entrepreneurship and economic development, and we also have big data analytics for space exploration and settlement. So we do some very interesting work in technology development and with entrepreneurs who have a lot of great ideas for using big data analytics and the value of those analytics insights to go into space and learn more from it.
Hello, Chris Biddy, founder and CEO of NewSpace. We design, build, and operate a constellation of remote sensing satellites. So we focus on producing the data and delivering the data so that these guys can learn from.
I'm Jason Lohn. I'm a product lead at Orbital Insight. We're a geospatial big data company that processes petabytes of satellite data and finds applications that our customers.
Okay, so thanks for those brief introductions. So let's just take a big step back here. I often like to remind everybody that what NewSpace is all relative. So in the 1960s and 70s and 80s, there was a NewSpace industry that is now fairly well established. Initially that was communication satellites, eventually remote sensing satellites came into. Anybody want to give us an overview of how remote sensing came to be and what it was like when remote sensing technologies were actually NewSpace and how the market's adapting today? Tiffany, you've written about this. Sure, I mean, in space, satellite imaging is where we're starting today. You guys all either collect or process data that's used in space to derive greater value from it than has been derived in the past. Right, so you're relying on a certain infrastructure of either existing satellites. I believe it's your company that relies on visual globe imagery. I'm sorry, and others are actually launching their own satellites. Right, so let's just start by just setting the table here, since not everybody knows necessarily what the state of the market is today.
So I was born a little bit after the 60s and 70s, but what I know is that what I know is that remote sensing at that time was almost completely government. It was intelligence applications. It was very expensive, very, very expensive. I think the difference now is that with the advent of CubeSats and agile aerospace, NewSpace, it's turning into more of a focus on commercial markets, not so much just pure government. The costs are coming down that you can operate satellites for much smaller markets, not necessarily a huge government budget. So I think that's my attempt at answering your question.
And when you say build and operate satellites for smaller markets, what do you mean? That the sensor package is different, or that it's collecting data more frequently?
Yeah, so I guess what I would say, smaller markets, small satellites, less expensive satellites can satisfy markets that could not be satisfied previously because there wasn't enough budget, for example. So now smaller, less expensive satellites, constellations can satisfy more specific, smaller niche markets that couldn't be satisfied previously. I think some examples are specific agriculture applications. That's actually what Aquila Space is targeting. So rather than requiring a huge national defense budget for launching and operating remote sensing spacecraft, now you can satisfy some of these other markets that don't necessarily have that huge resource. Even say disaster monitoring, which is somewhat hard to find, right? Going back to agriculture, small, inexpensive constellations can enable new markets like precision ag, for example. So that's kind of what I was getting at as far as these lower cost constellations enabling and satisfying new, potentially smaller markets.
Okay, so I just want to remind everybody that we're tweeting on the NewSpace 2015 hashtag, I believe, and also the big data hashtag, so please feel free to jump in. It's a great way to get people's attention who aren't here and help spread the word about the conference. So I think it might be worth just getting a sense from all of you about the state of the market, both in the underlying satellite technologies, who your competition is, say from drone-based data collection, and then what the big data angle is to this. What is it you're doing today that's different from what's been done in the past? Anyway, it's open for anybody who want to take those.
So what we do, basically the current state of the market, as Chris alluded to, is that new applications that previously were not possible, were economically not feasible. Right? Previously, if you wanted to do EO imaging, by previously I mean probably in the 80s and 90s, you had to be a massive government and you had to spend a couple $1 billion and you had to have an entire agency of scientists and engineers to design, build, test, launch the satellites, and downlink the data, analyze it. So all those parts in that chain are now basically commoditized. All of it can be done in the commercial sector, and that basically enables companies like ours that we establish direct relationships with the people that own and operate the satellites. And those are private companies, not governments. Private companies that have done the entire thing. They've designed, tested, implemented, launched, operated, and downloaded the data. And we take the data from multiple providers and answer some key questions, specific questions to specific locations on Earth for people in different industries. Who our competitors would be, so we're mostly satellite imagery driven. That's because there's parts of the world where it's quite tough to fly in a drone or an airplane. It's all fine and good that you can fly it around San Francisco and San Jose, maybe around in Central Valley in California and do the agriculture. You're not going to be able to fly a drone around a Chinese port or fly on an airplane over Brazil or India or Russia indiscriminately. You're not going to be able to do that for obvious reasons. Well, but you can. So that's the main differentiator. Is for highly localized uses like agriculture, precision agriculture, a drone or an airplane might actually be more appropriate, and in some instances can be more cost-effective than a satellite. But start talking global coverage, and when you need large areas, you need persistent monitoring in remote parts of the world. It's quite hard to beat.
So let me just ask you there. All right. So what's the resolution limit? The federal government in the United States set a
37 years.
So that's the maximum resolution that satellites for commercial purposes that American satellites can collect. Are foreign satellites collecting available greater resolution than that? Do we know? It's okay if you don't. But where I'm really going with my question is, how does that compare with the data that's collected by aerial or drone technologies where it's legal to actually do so?
Well, I cannibalize it.
Well, yeah, I mean, to get you lots of coverage, right? Because they're always orbiting the Earth. Aerial and imagery, the challenge there is to get the frequency. You're getting better resolution, but you're not getting, unless there's massive numbers of UAVs and high altitude aircraft flying, you're not going to get the coverage that satellites do. But you get better resolution, so you're interested in a specific point of interest on the Earth, and you can get a UAV or a high altitude, like a solar powered plane or something, to loiter and give you high resolution all the time. That's you'll get high resolution and satisfy the data that you need to get from that area.
And it's probably worth noting, as many people in the audience here know, that the FAA has been dragging its feet on letting Americans use drones. And it's just come out with new rules that are very restrictive, that don't really allow you to use them except over essentially unpopulated areas, which is probably a great thing for satellite-based providers, because that's going to continue to be the best way to image cities and pretty much everything except for agricultural, industrial uses.
I mean, a company like us at Orbital Insight, we're agnostic and very greedy for data. We'll get it from a provider that will sell it to us, that will satisfy our customers when we run our algorithms across the data. So we're fairly agnostic about where we get our data from, and that includes the different types of platforms and the different types of sensors.
So let's talk about the big data angle here. So you're getting more data from multiple sources, and you're getting more data, more images over time. So it's like in the 90s, those of us who remember using the early days of Google Earth and when there was satellite imagery available, it was very exciting. But it wasn't updated very often. There were very few satellites, they did very few runs. You now have more satellites, you have more data coming in. What does that let you do, and what's so magical about big data?
Does this work? Okay, so I guess we'll split that question, because that's basically the very reason why companies like ours can exist. As there's more and more satellites, you get higher revisit rate at any one spot on Earth, right? It used to be years, or it used to be never. Then it went once in a blue moon, and then it went once a year, then maybe a couple of times a year. Now it's all places of the world. Europe and the United States are basically carpeted with coverage. It's high repeats. You get an image every week, almost even from the high resolution data. But I'm talking about less traveled paths, less traveled places of the world. They have 1 or 2 images a year right now. And as all these constellations are coming up, both the CubeSats, small CubeSats, and the fridge sats, the slightly larger satellites, and as you have dozens, eventually hundreds of them, you reach a point where you basically saturate the low Earth orbit, and something like that is being imaged, whether someone's requested an image of every single day, and even that's submitted. So the range of applications is just astounding, right?
Because once you start getting multiple images regularly of an object, you can do more with it for analytics?
Yes. Yes, of course. I mean, let's take this very hotel, right? I mean, there's something happening here today morning at around 9 or 10 a.m., right? A lot of cars arrive in the parking lot, right? I mean, multitude of reasons, right? And they're all going to leave probably around 6 or 7, right? If you image a month, well, you're not going to catch them. If you have an image an hour, if you had an image at 8 a.m., 9 a.m., 10 a.m., and so on throughout the entire day, well, you can probably tell what's going on in this hotel. There's way more cars than there used to be over the past month, and it's probably some kind of conference going on, right? So yes, if you have an hourly revisit, yeah, it changes the game.
But how does that change the world, that kind of big data analytics?
Well, right now we're just looking at basically monthly changes. Like the parking lot example is a good one. We've imaged 700 million cars. We've counted 700 million cars in retail chain parking lots. And even at a month revisit, or getting an image a month, you can actually glean a lot of information about how a retail. When you get down to weekly and daily revisits, you can just get more fine-grained information and open up a lot more applications. Like right now, when we count cars, we're looking at, and we're assuming drive to stores and they buy stuff. And if you look at the cars at a Walmart at 11 a.m. in the morning, you can on a regular basis across different Walmart locations. You can start building a good picture. You start going weekly or daily, that just becomes more color added to the picture. And it opens up more applications, like Paul was saying. You can find out what's happening in different locations. If you care about traffic, people driving cars to different locations. I don't know, a state unemployment office building. The cars there, that might give you a signal as far as how well the economy is doing, because more people are getting unemployment benefits and so forth. But the frequency is, the revisit frequency, I think, is a game changer, because once you get that resolution, there's a lot more you can do.
I'm going to bring Tiffany here, but let me just ask the audience, before this panel, how many of you were generally familiar with the term big data? Show of hands. Most people, very Silicon Valley crowd. How many of you are familiar with, for example, Google Flu Trends? Anyone? So this might just be a good example of this in the larger discussion about big data. So all of us, we use search engines every day, we put in search terms. Google discovered that by doing big data analytics on all of those search queries, they were actually able to predict flu outbreaks in real time, something that was long dreamed of by epidemiologists. They can look for particular terms that people search for, and they can spot to very geographic precision, down to the level of towns and cities and even neighborhoods, where flus might be breaking out in a particular area. Similarly, they've done that kind of work for predicting unemployment in real time. Examples of how big data is starting to come from unexpected sources. No one would have expected you could use those search queries or those raw data points to understand our world better, but there are some very beneficial applications of those things. So Tiffany, do you want to give us a reaction here about situating this discussion and big data based on space applications, the larger context of big data?
Well, I think big data is interesting. I think there are some really unique things that can be done with the analytics, because we're dealing with so much high-speed processing, so much cost reduction, at the same time that we're able, through analytics, to ask really meaningful questions, get those insights out of that data. So I think we're able to do a lot more than we used to do. I think the potential for space is huge, definitely huge. And it's not just looking at the Earth, it's looking across the universe, of course.
Okay.
What we can do is begin to enumerate and run algorithms on some of our scientific questions. And as we do that, as we become more predictive, we begin to build a business value chain, and that's where we really see the return from businesses like these.
We'll turn to that point about how big data is allowing us to better understand space, both on orbit and beyond. But before we do, any other examples here of maybe surprising uses of big data? You've already mentioned understanding retail trends better, maybe traffic management, but anything else to the audience, an idea of something that really is exciting that couldn't necessarily have been done through some other data set before?
I just wanted to mention kind of another general thing is that with the, and you guys can confirm that the high frequency imagery, high frequency data, sorry, with the high frequency data, you can get more information over short time scales, but then also as you build up your archive, you can look at longer term trends as well. So even frequent, quick trends also will have a longer term pattern. So as you build up that archive, I think you get some information out of that. Another benefit of creating all this data with these large.
Can you give us any examples? When your friends ask you about this at dinner parties, what do you tell them?
I don't know that I can give you a really good example, because we're so focused on the agriculture side that most of our discussions are among ag. So like something that we're looking towards in the future is like the variable rate applications of fertilizer and irrigation and things like that. And so as you build up this archive, you can see these trends. You can see yield patterns changing in the crops, different seasons, and find correlations in that data as you build up this archive.
Okay, because at yield patterns, that sounded pretty boring, but then you got into essentially feeding people better, and maybe lowering food prices and increasing crop yields. That sounds pretty exciting, especially for the developing world. So what do you think is the potential for that big data application to really improve the human condition?
Yeah, so I think that as you increase the of data, the frequency of imagery at the specific resolutions and specific spectral resolutions also, I think that what we will see is that you'll be increasing your crop yield for a given amount of like land, water, fertilizer. I think you'll see a much more efficient use of those resources as we're able to provide consistent, frequent feedback to the farmers, to the growers, in this precision ag.
And for those in the audience who are not engineers, can you just explain the difference between resolution and spectral resolution?
Yeah, so I was kind of throwing two terms around, but I'm discussing spatial resolution, which is the amount of detail in the image. So what is the size of one pixel on the ground? And then spectral resolution, which is what are the shape of your filters? So what wavelength of light are you collecting? So specific spectral resolutions will give you different information, like the NDVI vegetation index. By using specific bands, you can calculate NDVI, and from that you can determine different information about the plant, about the crop. So if you just do, say, panchromatic image, which is a white band image, you may not be able to extract the same amount of information, for example.
I think your question involved societal benefit. We do have an application, and we're working with the World Bank to help them assess poverty in Sri Lanka. So satellite imagery, obviously you see a lot of trees, you can see roads, the building of roads is an indication of where population clusters are, and you can tell essentially where people are living, subsistence farming, or living in huts from the aerial imagery. So that's a project that has a societal benefit. The other one thing I wanted to mention was NASA has a lot of data big data that has not really been fully analyzed. There's Mars data. There's satellites that have been orbiting Mars. There's lots of data, and a lot of it is the value of that data has not fully been unlocked. So, like a platform like Powell's and Orbitals, we can apply our machine learning and machine vision techniques, unlock some of that data that's science data.
So I always say that data is a great untapped natural resource. It's a way of understanding the world around us. Think about Google's mission, for example, unlocking all the world's information, making it universally accessible. So what I see you guys doing is you're observing the world. You're helping the developing world understand where people live, where they're moving, where infrastructure might be needed. Those are all problems that in the developed world we kind of take for granted. We assume there's a map somewhere in some engineer's office, but in a lot of places that doesn't exist. And so I want to just tie this to what the Space Frontier Foundation actually does. And I'm sure all of you have read the Credo recently, but it's worth noting that the goals of the Space Frontier Foundation include protecting the Earth's fragile biosphere, creating a more prosperous life for everyone, and using resources of space. I would say that observing the Earth from space is a space-based resource about the planet. So that's as important a resource as mining or anything else you might do in space. On the point about environmental protection, though, are any of you aware of any particularly relevant applications of big data to environmental protection or to making agriculture work better so that, for example, there's less need to just churn up forests?
Yeah, so there's already applications. There are companies that are highly specific on these environmental verticals for protection. There's a nonprofit that does deforestation tracking in the Amazon. So they basically have a live alarm that basically watches for the forest being cut down and issues an alarm to the relevant authorities in the Amazon basin, whatever particular country that might be.
They're using commercial satellite imagery.
Yeah. They're analyzing, they're actually using government environmental monitoring satellite Landsat to do that. You can use satellite imaging for way more exotic kind of uses. It's being used to track polar bears in polar bears walking on black
Aren't they
rock.
kind of hard to spot?
No, not if they walk on gravel. So a big white polar bear is about 3 or 4 meters big, and at half a meter resolution, it's about 6 pixels. So it turns out you can actually spot a polar bear from space. You can, and this is my favorite one, you can spot colonies of penguins down in Antarctica. You can actually look at it on Google Maps. There's you can spot penguins, polar bears, environmental. You can detect deforestation. You can of course detect, changes in land use patterns. So, urban growth, suburban sprawl, all that. So it's got applications in municipal planning. It's somewhat traditional uses that remote sensing has been used for since the 70s or 80s, but it was a very slow, very expensive process.
And how is big data changing those kinds of applications?
Well, you make it cheaper and faster.
Also make it more intelligent. Remember what we do with big data analytics. We loop back what we learn from the analytics to improve the big data platform, the processing. So it's not just that it's cheaper and it's faster, it's also of better quality. So whatever it is that we're doing, we can get more operational intelligence on the platform. We can learn more about the domains that are. And when we do that, we also make possible our ability to more speedily learn as we go along. So we can loop in live curation on these very deep expertise levels that we experience as we start doing these analytics.
So you mean that you might notice a pattern in the data set and therefore look more carefully for things like that?
Right, and an expert could be pulled in and look exactly at that data. So if there's a natural disaster that involves expertise, say in, I don't know, nuclear fission or something, then somebody can look and say, okay, this is the expert specifically, and curating the data as it goes along so that the next person who's looking at it then has the benefit of that knowledge. We can very much speed up our responsiveness to things that go on and also make it easier for us to build in a much more effective way.
So I want to turn to the space part of this, but before I do, let me just ask each of you, where do you see the space-based big data industry going in the next 5 to 10 years? Is it better, faster, cheaper? Is there anything in particular you think that's going to change qualitatively?
Oh, I think there's going to be a phase change. Once you get to sub-daily revisit on a global scale, so every square foot of the world gets imaged every single day, that will enable new applications that just were not even thought of before. So it's going to be beyond just faster, cheaper, and better. I think it will just engender a completely new kind of society, like total information society in many ways. But basically, you will be able to see every spot on Earth. So a new Google Maps, new day by day after day. It's unfathomable what that will lead to, really.
So I'm a privacy lawyer, and I spend a lot of my time dealing with people who are very concerned
You'll
about
be very busy.
what you just described. So do you think there's going to be a lot of pushback against that idea?
Certainly. But you can get angry, you can push back, but that's about all you can do. I mean, you cannot ban technology, and also, as we always talk about, remember, even at the highest resolution of satellite imagery, you can't see individual humans, right? So you don't have to worry that someday when you're at backyard, it's like, humans still pretty small, right? The cross-section of a human is about a foot, so it's one piece.
Just to play devil's advocate here, because I'm all in favor of what you call total information society. I would call that the transparent society. That's David Brin's term from his great 1997, I believe, book, The Transparent Society. But people might say, okay, well, you can't see me, but you can see when my car is there, when it's not there. You could potentially track my movements. You could tell things about when I'm not home. What might you say to that, and how is the industry addressing those kinds of concerns?
I would just point out that Google Street View is blazing the trail there, right? Because it is a very sort of invasive. It's driving everywhere. It's getting people, numbers, signs, and all sorts of stuff. And there have been lots of legal cases about countries. And Google is kind of on Street View. I think some of those precedents that get set legally will probably satellite and aerial imagery.
So that's a great example. Of course, Google has taken some specific steps to address concerns. Algorithmically try to remove human from the images.
License plates.
License plates. And they also have a tool then where when you use Google Street View, you can report an image, you can ask to have stuff removed. My best friend really likes the Google Street View image of his house because it shows his dog out playing in the yard, and the dog's been dead for 6 years, and anytime he wants to go remember him, he goes to his house and he zooms back. Many people don't know this. On Street View, you can zoom back over time to see their data set. It's exactly like what we've been describing today about seeing multiple images. But this is worth thinking about. As a space lawyer, I think it's the untold story about all this is the heavens and the earth, the great Walter McDougall space history, basically argues that Eisenhower allowed the Russians to go first, that the United States could have launched satellite first, but Eisenhower wanted the Russians to flip their position, because before they launched, they had insisted that just as they opposed overflight by spy planes, they opposed overflight by satellites. And then, of course, once they launched their satellite, then they, of course, flipped their position. And what he created was a transparent society, total information awareness at the resolution level of the 1950s and 60s. But he established the right of peaceful overflight. And now what we're really seeing is, okay, so you can drive Google Street View down the street and collect images. Maybe you can fly a drone in certain areas, and you can fly a satellite in someone's house. So those are all perfectly legal. We're getting questions for drones of, okay, well, if you're over someone's property, how high do you have to be? What rights do they have? And then with satellites, even if the resolution level doesn't change, the data does become more granular, and big data might allow you to identify patterns that people would be concerned about. Now, I'm not one who would say we should restrict those technologies, but there are plenty who would, and especially in countries like, for example, Germany, where Google Street View was, I believe, actually shut down. I have to actually check, but there was certainly a great furor about it. Well, no pun intended.
I mean, when it comes to information, and just more and more information, more and more data, my personal vision that inspired me is like, for those of you that read science fiction, read Snow Crash, right, from Neil Stephenson. It's an awesome novel, and it was written in like 91, and it actually predicts a lot of what's happening now, more and more satellites, more and more imaging, and it takes it to its sort of logical conclusion of just information society, and it's
But a lot of people wouldn't want to live in the world of Snow Crash.
well, yeah, it's a good objection. We'll see where it goes.
Anyone else on the privacy point before we move on? Okay, so let's talk about the space point. So we've been talking about how big data analyzes the Earth. Tiffany mentioned that big data analysis is actually changing our observation of the rest of the solar system, of the universe. Can you elaborate a little bit on that?
Sure. We're building huge arrays to look out into not just the solar system, but the entire universe, and all of those will be collecting a lot of data, and we need to analyze that in different ways, not just looking for occultation, but for a variety of factors. Chemistry, all kinds of different things that we can start analyzing. And because it's all data that we're like a big data analytics system, we'll be able to make comparisons all across the universe very easily without it being the assignment of a particular astronomical team to look for something, and look only in a small area.
Can you give us any examples of how big data analysis has actually changed the way that those scientists are working?
Well, I think it's a lot easier to see similarities. So if we go looking for large planets, we can find some and we can compare them. We can see what their suns are like. We can see whether they have anything in common with Earth. So we can ask them questions about their commonality and questions about how they compare to Earth and what our needs are. So we can start making demands of the data and driving our analysis in that way.
What about our sun? That's kind of important both for environmental reasons and for industry. A lot of operators of power grids, other technologies, satellites themselves are very dependent on notice about solar flares. The climate change debate revolves in significant part around data about the sun. Anyone aware of the latest on updating, or I believe there was this contract out to replace the US government satellite that's been doing solar flare observation? Ring any bells? Someone in the audience might know more about that, and so they're welcome to chime in.
They've gone predictive, and now they're able to predict solar flares a lot more easily, and that's due to algorithms.
Well, I want to open this up to questions from the audience before giving everyone a chance to wrap up. But anyone want to tie up any loose ends from what we've discussed before we open it up?
Yeah, I just wanted to address your question about what's next. And I think from the space side, you're going to see imagery of all spatial resolutions, and you're going to see a lot more, you'll see a lot different spectral resolutions also. So I think we're going to see just a lot more data, period. Not just 1 meter systems, hourly, for example, but I think you'll see 1 meter data, 5 meter data, 20 meter data. So like your example of the Google Earth, you'll have daily data at each level of zooming in from broad coverage all the way down to maybe 1 meter, maybe sub-meter.
And is that primarily because the availability of small satellites, or is it because companies like SpaceX are promising to significantly lower launch costs and revive the dream of launching larger constellations?
I think it's both, and I think it's driven by the different applications that require this different data set, different resolutions. So I think the low-cost launches and the low-cost small satellite constellations will enable that, but it will be driven by these various applications that require different data sets.
Okay, well, with that, let's just open it up to questions. And for those that are watching on the live stream, being live streamed, happy to take questions by Twitter as well on the NewSpace 2015 hashtag. While we're waiting for questions from the audience, I can always count on Joe Carroll to ask a question. He's on a short tether from the microphone.
Okay. We now do compression of image data that you see, JPEG or JPEG 2000 or whatever. Are people doing more information mining in orbit, or do you see that being done? Train classification, more sophisticated processing, just to limit how much has to be downlinked? Because right now, I suspect that collecting the data costs money, delivering the image costs money. Processing on the ground costs money. I think that the downlink is a non-trivial part of the total. I'm wondering about compression to the level of information, not just compressed data.
Almost all analysis is done on Earth now, of course. And there are plans, though, to put some computing in space, and that will allow us to do exactly what you suggest, to have more processing done in space without the downlink. But it's a lot of startups and entrepreneurial ideas. Some wanting to deploy clouds of compute clusters. So there are plans to have these as satellites around the Earth. There are plans to put a cloud of little satellites on L5 where there's a reasonably stable orbit. There are a number of different approaches to the problem. And that would be really convenient because a spacecraft could pull right up next to the compute cluster as if it were a data center and borrow all of its compute power.
So cluster, would those would be for satellites that were doing something other than Earth imaging? Observing the sun or the solar system or very remote Earth imaging? What would be the application?
Well, in theory, we could offload, just as we do to a different data center here on Earth, we could offload data processing up to that particular cloud if we wanted to. It wouldn't have to be localized. But if we wanted to reduce the transmission time and have something local there, then we would probably have scopes out there looking out at the universe rather than at Earth. But you never know, maybe by the time we put something out there and look back toward the Earth, we'll find that from that distance we can see something better.
So I find this fascinating because this is really the intersection of what I do, which is internet policy with space. I'm a little skeptical about the idea of basing so much in space, only because A, the launch costs are still quite high, and even if they fall significantly, Moore's law suggests that there's always going to be a significant advantage to basing stuff here on the Earth, that you can just upgrade the computing processing power here on Earth so much more cheaply than you can, given the time scale needed to plan a satellite, launch the satellite, and have it in orbit.
But it doesn't solve the downlink problem.
Right.
It becomes a dominant.
Right. And so at that point, let me just ask on the, and again, I'm a satellite, was a satellite years ago, so my knowledge is a little bit dated, but generally speaking, there are greater downlink capacities now with being able to use other bands. Anyone want to comment on that and how it drives your applications?
Yeah, so you're absolutely right. The downlink is typically the bottleneck, especially for remote sensing missions where you're generating a lot of data with the images. And you're also right that as you go up to higher frequency bands, you have more spectrum available. Downlink, you can increase it quite a bit. That's something that our company has been really focused on because we see that as a challenge to increasing the throughput of the system. And so one example that you mentioned or that we're looking at is actually projecting cloudy images onboard the spacecraft. So this would be a perfect way to utilize your downlink more efficiently. It's something that we're not currently doing right now, but something that I think is very logical next step, which are essentially increasing your effective downlink and utilizing your system much more efficiently.
Next question. You could just identify yourself.
Your time's cube tab. Do you see over the next 5 to 10 years significant uses for constellations other than Earth observation and communications? We hear about Earth observation, maybe your private cell phone network. What else is it good for?
Well, there's some alternate uses for CubeSats. You can do radio occultation through the atmosphere to get the weather. You can attempt to do communication satellites.
That's still Earth observation through the clouds. What other?
Especially that would be relevant to big data. Like for
I mean, it comes down to power, right? I mean, if you're computing, you're using a lot of power, right? And if it depends what's your power budget on a small CubeSat. I'm not a hardware engineer. From what I understand, it is constrained. It's a major constraint. It's your ability of your enough power. You can get around with it if you co-locate on the space station, which has these wonderful football-sized solar panels and generates lots of power. Get on the space station and put your racks, computing racks on the space station. It would work that way. But I think it just comes to basic engineering.
Do we know what kind of imaging or remote sensing, maybe other than Earth-oriented, that NASA is planning on station or in other satellites, such as Tiffany was mentioning? I don't expect you to know. This is a commercially oriented panel, but just in case.
I mean, I think there's some program. Our Earth observation platform being planned for this space station and other non-traditional uses of space station, including, of course, manufacturing parts in space, manufacturing satellites in space, satellites themselves being manufactured in space. So there's a whole lot of very non-traditional uses that you can really contemplate once you have the power of the space, physical space on the space station and lots of power.
Well, an Earthcast is from the ISS.
That's right.
I had a question about how much is enough. So every week you seem to be somebody else wants to launch another constellation of Earth. So 1 was good. 2's all right. Okay, 3. But 12, 15. I mean, how is there really the value for that? Is the customer base really there to support that? And then, where do you get to the point of diminishing returns?
I mean, as a market fundamentalist, the market will answer that, right? I mean, it's just once you start, once you launch too many CubeSats and no one wants to buy your imagery, then it's time to stop. Or as is the case, like from what I understand, like in the 1850s when Britain was manufacturing steel, they hit this way how they could increase the efficiency of manufacturing steel by like multiple fold. Well, it didn't actually increase. It didn't mean that there was like less time spent manufacturing steel. It just actually massive overall increase in the total output of steel manufacturing. And I feel this could be something similar with this, just no end to the amount of applications that could be envisioned using this data. So, I mean, eventually you'll saturate the lower Earth orbit, so I think there's a physical end if you have too many satellites per square kilometer, but I see no end.
Yeah, I mean, I'll second what Pavel's saying. The market will eventually answer the question. As Pavel likes to say, he'd like to see the sky black, satellites up there that through.
Not quite, but if you're not careful, you can get to that point.
So there's other sensors that could be, there'll be new sensors, right? So there's lots of platforms that go up, new sensors, new information, and then on the ground side with the algorithms, machine vision improving, deep learning, machine learning techniques getting better and better. It doesn't feel like anytime soon we're going to saturate.
Agreed. Yeah.
So I'm reminded of the Jevons paradox that says, the great economist Alfred Stanley Jevons, who said that greater energy efficiency actually ends up producing more intensive uses. And similarly here, what I'm really hearing you say is that the more data is available, the more we can do with it. In fact, more of a market there will be. I think that assumes that there are applications out the long tail that someone's going to think of a way to optimize whatever, the design of parking lots or to do agriculture better. This is my point about Google Flu Trends. We don't know what all the stuff is in the long tail. It's not known today. It's probably not cost effective today. But as processing costs come down, as you're able to use your links more efficiently, all of your companies, it sounds like we're betting that there's going to be a market out there of many areas of the economy finding data. Sound right? Yes? All right, next question.
This may be the wrong group, but it came up here. You're going to have hundreds and hundreds of satellites without any propulsion. And they're going to, at what point do they start running into each other? Producing lots of little fragments to hit the other satellites, to hit lots of little fragments to hit the other satellites.
So he's trash talking your industry. What do you say to that?
So, well, I'm not an orbital engineer, but from the basic physics, what I understand, the satellites go on different altitudes and different orientations of their orbits.
Plainly.
And so they're not really going to start crashing into each other anytime soon. They also decay pretty quickly. So when you put a CubeSat on really lower orbits, they decay within a matter of months, sometimes even months or a couple of years. So it's self-cleaning problem.
So it's worth pointing out here, the satellites you guys are using are low Earth orbit. They're in polar orbits. Is it fair to say that you're a lot less worried about the debris problem than, say, for example, the geostationary operators who are using satellites for satellite television?
I'd like to comment on that. I did a rough analysis for CubeSats, and the cumulative contribution to the debris problem is roughly scales with the 21st power of the altitude. Okay, fly low. Not only do you get better resolution from a given size aperture, but you don't stay in orbit as long. There are fewer things to run into, and if you create, will deorbit quicker, and those both all stack up. If you fly 20% lower, you may stay in orbit only 1/8 as long, but you create 1% as much debris. So fly low and reboost in place and be able to dodge the few things shouldn't be a problem.
Words to live by. So let me ask you a question, Joe, or anyone else here knows anything about space debris. It is a problem I'm concerned about. Are we getting better data on debris? Are we able to do big data analysis of debris?
We have been doing a very good job of analyzing the second most serious part of the problem and totally ignoring the first most. The problem is not trackable debris. The problem is little fragments of which there may be 10 to 100 times as many as are being tracked.
So it's the
They
known.
have enough mass. So I describe it as the attack objects are like cars, okay? The track fragments are like hubcaps. And just as with cars and hubcaps, there's 4 hubcaps for each car right now. Right? But for each car and hubcap combined, there may be 20 or 50 pieces of shrapnel that are too small to track with the current equipment, but have enough punch to take out a $1 billion asset. And we are ignoring that.
So it's the known unknowns. Okay. Any other questions?
One other thing. We have not tried to estimate the cost of orbital debris. We've estimated the cost of various means of removing it. We don't know how much is a good number to spend because we don't know how much ignoring the problem costs us. We don't even know how many spacecraft have failed due to it.
Sounds like a job for big data, if we actually had the instruments collecting the data. Any other?
Yeah.
One other.
At what point do you think all this data might become a national security issue? Giving access to all the security data to non-state people that might be able to look at it for drug trafficking or terrorism or something else like that, having access to all this data?
Well, go ahead.
I mean, the first law, at least in the United States, is that the government regulates what satellite providers can sell, you know, location-wise and resolution-wise.
I mean, you still could see immigration patterns at the border, know how to penetrate that, those types of images.
Yeah, Orbital Insight will do background checks on all our customers and make sure they're good people.
It's as you say. Let's just remember that the U.S. Traditional U.S. commercial operators, GOI and Digital Globe, built satellites that eventually were able to provide resolution below the commercial limit. It was available only to the government, and they were able to sell the rest of that to the private sector. And this essentially was a way for the NSA to share the costs of those satellites with the private sector, because the private sector would buy the imagery wasn't concerned about. But what your question highlights is, now we're not so much concerned about the resolution, we're concerned about the big data analytics patterns.
It's about the real-time nature of it, right? I mean, if you take an image once a month, you can probably glean some kind of information out of it. But if you try to do that like 10 times a day and you're getting real-time information, there's many different uses for that, right? And whenever there's data, there's going to be some misuse of that, right? So, privacy is one thing where you can say, oh, we object to privacy, and it'll fall on deaf ears. But national security is something that I think it'll be a bottleneck at some point when this data becomes readily available.
Well, I mean, there's many different ways to look at this, but like bad guys already have cameras, right? People walk around with phones, they take pictures of things. There's cameras, there's security cameras installed. People have, there's the internet. You can openly browse through the internet and create quite a bit of damage. And that's not a reason to ban internet, right? It's just policing data hygiene and just establishing certain security practices that the market and in collaboration with the government will establish to counter those threats.
And in addition to what's readily observable by anyone over the internet, if it's an investigation, there is a warrant, and then there is the data collection against the particulars in the warrant. So similar to wiretapping, there has to be a warrant there
That's why I
for the
think there's a
person to be
certain.
observed.
That's why I think there's a certain point at which that will start to become a concern. I don't think it is there right now, right? But I mean, there's many other different objections you might find, which are, I don't know, corporate espionage. I don't think Walmart wants you guys scanning their parking lots, right? I mean, you don't want Apple doesn't want you guys scanning their supply chain, right?
The example I'll give you is like, when Facebook began and people started uploading their private information online and sharing it with the world, people freaked out, right? And people are like, why would you put your private information into Facebook, right? And just like share it with the world. It's really weird, right? And what Facebook has done, they have completely changed the way people perceive privacy. The way you perceive privacy and your children perceive privacy are very different, fundamentally different. And I really believe that openness and privacy, these data, what they will reveal about our world, it changes on a daily basis, which has completely changed the way we view what needs to be hidden and what needs to be revealed.
So that the privacy issue is something that is is a separate issue from security, and that's why I was trying to bring it up in context.
Yeah, so hold on. So you and I are in total agreement. I'm also what you call a market fundamentalist, believe in the total information society. But I think your point is just about realpolitik, right? So there are obviously applications of these data sets that could be create national security risks. And so it was already alluded to that one of the restrictions on data today is not just resolution, but particular areas. So I assume it's the case that if I'm whatever cartel in Mexico and I go to one of your companies and I say, I do images of the U.S. border, could you help me do big data analytics of how the U.S. border guards are moving? Let's spot a good place to go through. I believe that's already addressed today because that is a restricted area and you can't sell imagery of that area. Now, the harder question is, what if some big data scientist who discovers jihad decides that he can use your data set for on critical? I mean, you can imagine all kinds of things that maybe don't seem likely today, but in the future, especially are used, you could imagine people wanting to find patterns so that they could plan something really terrible. Or maybe even more realistically, so they could plan their wars, right? These data sets could be very useful for somebody who is planning on invading. Any thoughts on that?
Well, it's a tough one, right? But I mean, every measure elicits a countermeasure. Right? If this technology can enable it, then you can enable appropriate countermeasures, right? I mean, it's just the example you have cited of people using open tools for nefarious purposes has happened, for example, in Iraq, right? I mean, early stages of the insurgents used Google Maps to plan that attacks, right? Because it's ideal for them, right? Yeah, that's a really bad use, nefarious use of this kind of technology, and there are ways how to minimize that threat, and there are ways how to that threat and work with a variety of stakeholders. So from law enforcement to government and legislation to make sure that it's a policing issue. It's like we have to be as police.
Well, one thing that makes it easier for companies like Orbital is we don't sell pixels. We sell insights and analytics. So we know what our customers are up to in the end, and common sense will take out 90% of the bad actors out there, and then for the other 10%, we just got to be really smart and just not get in trouble.
And I would just remind everybody of what I think was Eisenhower's great legacy, the one for which he'll be remembered for centuries. It's not just keeping the Cold War cold, but it was transparency, and that was really the way to do that. Because had Eisenhower not did what he did, it would not have become possible for satellites to observe the movements of troops on borders. Right? The world changed fundamentally once commercial satellite imagery became possible technologically, but legal as a matter of international law. Because on the whole, whatever else it may be used for, and certainly I'm sure has been used for ill in some cases, on the whole, a transparent society is a better one. It's one in which you can't plan to attack your enemy. We knew exactly what Saddam Hussein was doing when he planned to attack Kuwait, for example. Didn't stop him, but we knew we were able to go in fairly quickly. I'll just stand up for Eisenhower's legacy. That we are going to have a fight about this, and on the whole, the forces of transparency will probably win, but it won't necessarily be easy. Any parting comments on this point? Any final questions from the audience? Okay, so let me just go down the panel, starting at the end over here. Why don't you just wrap up with whatever you think is really the most important thing from this discussion, or that people haven't heard today, for the audience to take home.
So the new startups are going to generate, new satellite startups are going to generate at least 10x more data than we've had in the past. And in the next couple of years, it'll probably be 100x. So you need big data techniques, you need advanced machine learning, advanced machine vision to process all. You can't look at it manually. I mean, you can, and the government does look at images and geospatial data manually, but at that scale, it's all algorithmic. You've got to have algorithms running in the cloud, probably most, 24/7, crunching all that data. And we just see a big future in geospatial big data analytics.
I think just bottom line that we're going to be producing so much more data that there's going to be a creation of so many new applications and new things and new insights from the data that I think it's a pretty exciting time.
I think we're going to have a lot more quality of our data and our inquiries as well, and we're going to learn a lot. Our learning will become so self-prepared and self-engendering that we'll be teaching great things to computers, artificial intelligence, and they will turn around and teach great things to us as we go out into space.
Yeah, I think this technology, or CubeSat and the imaging explosion, really has the potential to change society in a similar way in that it has changed formerly military technology that was commercialized, and in the same way as internet really changed the society. I think this will be, again, one of the major technological inflection points, and the future is awesome. I think it's going to be amazing.
For my part, I'll just say that I think that's probably right, and that in part is going to make people more aware of space technologies in their lives. I mean, I always said that in the 90s, people started getting satellite television, and they didn't know that it was from a satellite. It could have just been from any kind of radio transmission. It wasn't fundamentally different from putting up rabbit ears. So unless you were a real geek and you went out there and you looked down at the equator, and to satellites at night, it didn't really mean that much to you. I think one of the social tipping points for people caring and knowing about space was Google Maps, Google Street View, actually Google Earth, and getting that satellite data there. I mean, that really made people very tangible to space. For my generation, it was a little bit like I understand seeing the Earth was for the generation of the 1960s, right? It was a way of reconceptualizing their universe as seen from space in a way that forced you to think about how did that get there? What are those technologies doing, and how can I, as a young person, get involved with that? What kind of career can I make in that area? So that, as a social matter, that's a good thing. All of your businesses are building a sustainable space economy, right? And they're helping to actually build a value chain that makes it worthwhile to do things in space, whether it's Joe Carroll's tether technology or orbital debris mitigation or whatever. It all requires having useful things, that value being created in space. So I think the bigger the space economy is, the better. And on the last point, we didn't really touch on this, so if anyone wants to jump in on this, feel free. We have a little bit of time. But I'll just say, Space Frontier Foundation is all about space settlement, ultimately. And if you take away one thing from today, I would suggest that often the debate about space is, well, is it going to be robots or people? What's the mix of robots and people? Well, don't forget data, right? I mean, everything that is going to be done in the future of the species is going to revolve heavily around crunching data about every aspect of how we live in space and what we can do in space and resources in space and characterizing asteroids and learning about other planets and learning about the Earth. And so all of the technologies you're describing today, they may be focused on the Earth, but they're all going to be used for other purposes, and they're going to be big data scientists in the future who are going to be crunching numbers for solving all the problems that everybody at this conference works on, whether they're human conditions in space or economic conditions for exploiting the resources of the solar system or whatever. So I'm very bullish about big data, but I'm also a market fundamentalist. So we'll see. Any parting reactions to that? Okay. If not, is there anything I need to tell anybody about the next panel or tonight? Just remember, you don't have to leave at 6 or 7, as was alluded to earlier. There are parties going on tonight. I believe there's a Serenity party going on around 10 o'clock, so stay tuned for that. And otherwise, please join me in thanking our panelists, Jason, Chris, Tiffany, and Paul. Thanks.